Now we solve a rational inequality. You know it's a rational inequality because we see a ratio. We have an added worry that you can't let the bottom be 0. There is a domain restriction. We find the value of x restricted from the domain by setting that denominator equal to 0 and solving. Now we know that x cannot equal 6. So the domain really is all real numbers, just not 6. Keep it in mind. Okay, we do have the 0 on one side. We do have just one fraction. We are on the quest for our critical numbers or boundaries. We find them by setting the top equal to 0, setting the bottom equal to 0, and solving. We've got -4 and +6. We're going to use those values to break up our number line and find out where the answers lie. So let's take a look. We've got -4 over here, +6 there. We're not sure. Are the answers on the left, in the middle, or on the right? To figure out, we're going to test a value from each region. Let's test something not on the line. How about to the left of -4? Say -5. Something between the -4 and the +6. How about say 0? And something to the right of 6. Why not 7? Okay, well we test them by plugging them into this inequality. That's -5 plus 4 over -5 minus 6. We want to know, is it greater than or equal to 0? The top makes a negative. The bottom is negative. If you divide two negatives, that turns into a positive. To say a positive is greater than or equal to 0, that is true. So we know our answers do lie on the left. That tells us that -5 is an answer, and all the numbers with -5 are answers. Let's shade that region. Now we test 0. 0 plus 4 over 0 minus 6. We want to know, is it greater than or equal to 0? That's a positive divided by a negative. When you divide a positive by a negative, the result is negative. To say that a negative is greater than or equal to 0, that is not true. We know that 0 is not an answer, and all numbers in the middle are not answers. Let's test 7. 7 plus 4 over 7 minus 6. We want to know, is it greater than or equal to 0? The top is positive, the bottom is positive. If you divide two positives, you've got a positive. To say a positive is greater than or equal to 0, that's a true statement. So we know 7 is an answer, and all numbers on the right with 7 are answers. So we are shading the right-hand side. We found our answers to be on the left and on the right, not in the middle. Now we have to choose if we're going to use brackets or parentheses. Because we have equality, we are trained to use brackets to include those critical numbers. So here we go, drawing our bracket. And then we go to draw our bracket over here, but hold up, oh no, hold up. There is one number that x is not allowed to be. The only number restricted from the domain is 6. That was our value on the naughty list. So we've got to use parentheses here to indicate that our answers get really close to 6, but do not touch. Let's draw this graph again. It looks a mess. At -4, +6, we shaded the left, we used brackets. We shaded the right, we used parentheses because x is not allowed to be exactly 6. Our answer in interval notation, there are two intervals. On the left, as low as -infinity, up to -4, including -4. Stop, stuff is missing in the middle. On the right, as low as 6, but don't include it, up to infinity. That's our answer in interval notation.